Now, I've said that where arithmetic is that part of mathematics which has numbers in it and arithmetic operator symbols, a plus sign, a minus sign, multiplication, division, and so on and so forth, and parentheses and all of those kinds of things, equal signs. Algebra is that part of mathematics which has all of those things, as well as expressions such as x and y and sometimes z. And when we run out of these letters which stand for numbers, we might use, for example, x1 and x2, or sometimes we will see, for example, x with a little markup to the top right, which is x prime, and x double prime, and so, or y double prime, and so on and so forth. So all of these things are unknown numbers which appear in algebraic expressions, and those are termed variables. Variables. And when we have an expression like this, an algebraic expression, say x plus 3 equals 5, we know that x is equal to 2, because in this case all we have to do is to subtract 3 from each side. X plus 3 minus 3 is just x, equals 5 minus 3, which is 2. So x equals 2. Now we can put that back again. We can put the 2 in place of the x to check that we're right. 2 plus 3 equals 5. Is that true? Yes, it is. So this value of x, the number that we put in place of x, which makes this expression turn out to be true, is called a solution. So x equals 2 is a solution of this algebraic expression. It's a number, in other words, which, when put in place of x, makes the expression true. Now there may be, as we said before, other solutions. Suppose we have not one variable in an algebraic expression, and we dealt with this in the previous video, but two. Let's suppose we have x plus y equals 5. Well, then we have various solutions. We know that x equals 2 and y equals 3 is a solution, because why? Because if we substitute 2 in place of the x and 3 in place of the y, then that turns out to be true. We also know that x equals 3 and y equals 2 is a solution. These little marks I'm just putting down here we call ditto marks, which just means it's the same as above. We also know that 0 and 5 is a solution. And if we know that 0 and 5 is, we also know that 5 and 0 is a solution. And so on and so forth. And we can go on and on and on figuring out solutions. Values for x and y, which, when we plug them in to this expression here, make the expression true. Now suppose we have another equation here where we're dealing with the same x and y, and let's suppose that the equation is a very simple one. Y is equal to 3. Well, of course, we no longer have all of these solutions, because this solution, for example, here, this one, won't work because here y is equal to 2, and now we're told that y is equal to 3. This one won't work because y is equal to 5. This one won't work because y is equal to 0, and so on and so forth. This one, however, will work because y is equal to 3. Now we can find out what x is taking these two. What is the correct solution taking these two together? Well, if y equals 3, we can simply plug it in back to the first equation. So we have x plus y, but y is equal to 3, so we can put the 3 in here in place of y is equal to 5. And we go through exactly the steps that we did up here to find that x equals 2. X equals 2 and y equals 3 is now, if we know that y is 3, the only of all of these solutions that will work, will make these two equations come out true. Now, where we have more than one equation involving these variables, which are the same variables in each case, which are, in other words, to be taken together, then we call such a pair or such a group of equations simultaneous equations. And all simultaneous, and instead of writing equations, I'm just going to abbreviate it to EQNS, and that stands for equations, simultaneous equations. And these two equations, for example, might be simultaneous equations in the event that the y in each case is the same. Y refers to the same number. Then we have to find a solution which fits both of those. And that solution is x is equal to 2 and y is equal to 3, because that solution makes both of these come out true. Now suppose we had these simultaneous equations, for example. We'll take the same one that we had up here. X plus y is equal to 5. And suppose we're told further that y is, and this looks pretty complicated, but it isn't, is equal to, that's supposed to be a 2x plus 2. And we're asked to find a solution for x and y, a value for x and a value for y, that makes both of those equations, those simultaneous equations, come out true. Well, we know that y is equal to this, 2x plus 2. So wherever y occurs up here, we can, because we're talking about the same y, we can instead put 2x plus 2. So let's do that. Let's see what happens. X plus y, which is 2x plus 2, so it's x plus 2x plus 2 is equal to 5. Now what have we got? X plus 2x, what's that? That's 3x plus 2 is equal to 5. Well, let's take away 2 from each side of this equals sign. What's 3x plus 2 minus 2? Well, it's just, of course, 3x equals, and we've got to do the same over this side. What's 5 minus 2? Well, it's 3. Well, if 3 lots of x are 3 ones, what's 1 lot of x? It's 1. So x equals 1. Now we can go back and put it in here. Y is equal to 2x plus 2. Okay, so let's just find out what that is. So then y is equal to 2x, but x is 1. What's 2 times 1? That's 2 plus 2. Now, hold on, I've got to get out a calculator and figure out what what 2 plus 2 is, I beg your pardon. Let me think very hard. Click, 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 dum, dum, dum. It must be 4. Now, I was only joking about using a calculator to do that. Even I know what 2 plus 2 is. So y is equal to 4. So what's our solution for this pair of simultaneous equations, these two equations here? Well, the only solution that makes those two true is x equals 1 and y equals 4. And we can put those values back in here just to check they work. 1 plus 4 equals 5. Yes, indeed it does. And 4 equals 2 times 1, which is 2 plus 2. Yes, indeed it does. That is a solution, and I give myself, in consequence, a nice check mark.